Well, thank you for joining us, guys. I'd like to say before we start that I am the guy from the picture. Only it's been a really long quarantine, so that's why the beard and the long hair. But being said that, let's get started with machinelearning.net. Well, ML.net is part of the .NET ecosystem. It is a way to develop or program something that, in other ways, it would be really difficult or complicated or almost impossible. It's like programming the impossible. For example, if you have a photo or a drawing, how can you define or tell if it is a person or a face or an animal or whatever? If you were just writing code, you would be looking for patterns like if it has eyes, mouth, ears. It will be really impossible. But this can be really easily achieved with machine learning. Another angle would be, for example, if we like to guess a car's price based on a certain number of attributes or features, or just some data, for example, the number of kilometers this car has, the brand, how old it is, etc. It could be hundreds of attributes or features that are being taken into account when at the moment of defining this car's price. Now imagine predicting this car's price manually, having all those data at your fingertips, and doing this with a programming language would be really complicated. But machine learning, you can do it in a really simple way. For the first example, you have lots of data in which you indicate this is a face, this is not. Or for the second example, you have many data in your data set, a lot of car prices based on certain characteristics. And having all this data, you can create and train your custom model to predict a car's price using ML.net. We'll be explaining what a custom model is in a few. Basically, an ML.net model is like a function where you ask something and it gives you the answer you are looking for, And because this model was created with your data and trained with your data that you have in your dataset collection, it becomes really good on doing the task you tell it to do. Well, you're probably asking yourself what ML.net is. Well, it's a framework for using and creating custom models of ML.net and being able to execute them in any application. When I say custom model, it means you create and train it based on a data set you have collected. It is extensible. You can use it along with deep learning with TensorFlow, which is a standard model system in deep learning, or ONNX or Nimbus ML with Python. Like we can see, it supports and integrates with many other frameworks. It's open source. And last but not least is cross-platform. You can use it with Linux, with Mac, and of course with Windows. You're probably asking yourself again, why using ML.net? Because of the large number of people that are used to and comfortable working with .NET and would like to learn machine learning, create custom models, and do not want to learn Python or any other language. But also, that is really important, is the fact that behind ML.net, we have Microsoft. And on the other hand, we do not know who is behind other services. And this is a big deal for many companies, knowing that Microsoft is behind this. ML.net or ML has been used for like 8 or 10 years in Microsoft internally. It's a framework that was used in several Microsoft products. For example, with Bing without recommendations, in Excel with Bing without predictions, Excel with chart recommendations, PowerPoint with design ideas, Windows 10 with Windows Defender, most of Azure products, and so on. It went under the name of TLC. What they did was grab all those algorithms that are involved in machine learning and put them in an API simpler and designed for the user. ML is very attached to algorithms such as regression, clustering, binary decision, or math itself, in a way that for a developer, if they do not have experience with this math part, it would be really overwhelming. The idea of ML.net is to abstract all that math involved in machine learning and offer the developer the opportunity to have all these algorithms at their disposal without having to develop them. So what I like to point here is like, instead of thinking how to develop the algorithm, ML.NET is about thinking the different business scenarios and mapping those scenarios with different ML tasks. That at the end, those tasks are the ones that use the different algorithms. To make this clear, for example, I would like to predict a value, like like I said a few minutes ago with the car, and I have a full data set with house prices or car prices or whatever, based on their many characteristics. The machine learning task to predict a value would be regression. Or for example, we have another scenario where I would like to classify something between true or false. And again, I have a large data set. But now let's say with opinions about a restaurant, and I would like to classify or determine if those opinions are positive or negative. Well, that would be a binary classification. This is a machine learning task of binary classification. And we have business scenarios. The business scenario is classify something and can be mapped with a machine learning task, which will be binary decision. So I can't stress this enough. Machine learning .NET, it's an API that gives you like the easy way to create machine learning models, thinking on tasks and not how to develop these tasks, because this is the part that comes with the API framework. Now we're going to see the model lifecycle. A custom model has two well-differentiated parts in its lifecycle. The first one would be getting, preparing, and putting the data as the algorithm needs them. Once we are good to go, the second part will be creating the model and training it. Choosing the algorithm we think is convenient. Once it's done, we can evaluate the model, creating tests, and check how good or bad, because it can not work at the first shot. The accuracy of the model is making the prediction, or how good it is or bad it is, making classifications, or whatever the task it was created for. Once we are happy with the results of your model, you can generate or serialize a file of the model and last use it with your application. This could be web, mobile, desktop, etc. You can use it with whatever application you have. The hard part is the creation and training of the custom model based on the algorithm you think is the one for your task. This can be really cyclical and manual, and you can iterate over and over and over each part of the cycle until you get the better results. Since this might take quite some long time, like a really long time, since it's basically try and failure, especially if you don't know very well the algorithms involved to use. This is where AutoML.NET comes into play. Like the name indicates, it automates the process of applying a machine learning to data. Given a dataset, you can run an AutoML.NET and iterate over data filterizations, machine learning algorithms, and hyperparameters to create the model that best adapts to your task. Again, you have to tell what you want to do, and AutoML.NET does the heavy lifting. There are many ways to use Visual Studio. There are many ways to use Visual Studio. We are going to see 3 ways. Like I have just said, you can spend a lot of time choosing the correct algorithm manually, especially if you don't know them. So for that, like I have just said, you have AutoML.NET, which is, like I have said, an automated process where you choose your machine learning task and you tell the task to be done. But the important thing is it gives you back the code. Once it's done, it gives you back the code. And again, I can't stress this enough, it's not about thinking the what to do, is thinking the how to do it. Because ML.NET matches with the task to be done. Machine learning, like I said, can be used in 3 ways. Auto machine learning with the API wizard. This is having a data set, training, evaluating, and see how good or bad the model is to perform the task it was created for. And once it meets our criteria, we generate the serialized model, and we are able to use it in our application. The second one is also machine learning in the CLI or the command line. I have a picture here in the slide. Tom, if you can, the part that shows this one. You can use it through the CLI or the command line, like we are seeing here in the picture. And the third one is manually writing the code in Visual Studio. This is the first one. This is the model builder, the wizard I told you. And the third one is manually writing the code in Visual Studio, which is choosing the algorithm you want and writing the code manually by yourself. That would be okay, because the hard part of this is if you don't know very well the algorithm to use. There are so many algorithms to use, and if you don't know them, like I said a few minutes ago, this can be very cyclical and manual, and you can iterate over and over and over. That's why we offer also machine learning.net, because it makes the heavy lifting and it's the easiest way to go. And well, it doesn't matter which of the three ways to use it you choose. Now we are in the part on how to use it with your application. And when it comes to use the model with your application, depending on the type of app you have, it's recommendable doing one way or another. For example, if it is a desktop app, you can use the code that AutoML.net creates for you, or the one you created manually, and that's it. But if the application is multi-threading, like a web application .NET or .NET Core could be, there are other ways that are more recommendable or efficient to do it. Basically, the model in memory can be a singleton, and that would be perfect. And the web application would be calling this one object through any HTTP request. And there wouldn't be any problem with this. But the problem we have is with the prediction engine that is not thread safe. So I cannot reuse it among other web application threads. And you should be creating this object in each HTTP request or each request. And for example, if you have a controller, each time a request reaches your controller, you should be creating an instance of the prediction engine, and this could work. It could work, but it has a cost of creating the object over and over, depending on the model. It can be really expensive. For this, you can create an object pool for your prediction engine, and so when each HTTP request reaches your controller, all you have to do is grab one from the pool, use it and drop it, and with this you can have a good performance. It does, and all you have to do, and you don't have the cost of creating the object each time a request reaches your controller. But doing this could be a really little bit complicated for experienced programmers. That's why ML.net has a APS.NET Core integration package to integrate the prediction engines with whatever your application is. And I would like to finish this part of the talk talking a little bit with Devops workflow with ML model lifecycle, because at the development level, it's not only creating the model and use it with your application. You have the application lifecycle itself. And as well, this consists of creating, training, testing, and deploying the model. We also have to deploy it through our CI/CD pipelines. And for this, we have certain techniques that we can implement, such as each time we have new data incoming, with continuous integration, we can trigger our pipeline and create a new model. But also, we can have some unit tests, not only the tests from our code, but some other tests to test our model accuracy with this new data. And for example, if it is less than 80%, whatever the percentage you would like to tell or indicate, the accuracy is, our test fails, and if this happens, it stops the application and model build. And otherwise, if it passes, the test pass, this will go on as expected, and you will build the application, the model, and this is cyclical, so you can iterate over, leave it with continuous integration, and leave it like that, and this could work. That's a little bit of DevOps I would like to talk to you guys about. So now we are going to go through the demo and the code walkthrough with my friend and colleague, Thomas.
Hello guys, my name is also Thomas, and I am a .NET developer here in Softvision, Argentina. So let's talk about how to implement this code in our .NET API. First of all, I'd like to say that machine learning, it's a Nugget package. You can download it just using the Nugget package manager, looking for Microsoft.ml. So that's the first step. Then you will have to give your application the data model. In our case, we are going to use two data models. One is used for better predictions, and the other one is going to have less accuracy. We built an application used for predicting if a review for anything it's positive or negative. And basically, we have two data sets. One contains around 40K reviews. It's composed by a 1 or a 0 tab and a review. The one it's used for positive reviews, and the 0 for negatives. So this is going to be our data set, and we are going to see how the accuracy of the model between the two data sets. So, okay, first of all, we have to define two classes. One, it's the review class. It's going to be used for mapping our training set. Here we have an ID. So the purpose of this ID is just for entity framework. So it doesn't matter. It doesn't really matter. Second of all, we are going to have this text property. This is going to help the review, and the sentiment is going to be used for the 0 or the 1 for it is positive or negative. And the review prediction, it's the class that we are going to use for make predictions. So here we have this review predictor class, in which we have some properties and path. And our entry point is a constructor. And we can see here two objects of the ML context class. Basically, this ML context class, it's the entry point of our application. For the .NET developers, it's kind of similar to the DB context. It's a shared object for our machine learning applications, and it's going to help our environment for doing all the things. So first of all, after instantiating this object, then we have to load the data, the training data, because the first thing to do is train the model. And for that, we have to load the data. You can load the data from different sources like text files or SQL Server or maybe enumerables, but it's just simple as that. You give the data path to the ML context, the class that it has to map, and then just with this line of code, you will have an eDataView object holding all the information related to the training dataset. So this eDataView object, it's going to hold our information in a tabular way. And it's going to be used a lot in our ML context and ML application. Okay, the next step is it's training the model. We basically have to use this method, trained test split. The only thing that this method does is splitting our training set between two sets. One is for training the model, and the other one is for testing the trained model. So you have to pass as a parameter this test fraction. In our case is 0.1. So 10% of our reviews is going to be used for testing if the model was trained properly or not. Here we have 2 lines of code related to the reuse data model. So it's basically the same as we saw before. And okay, we have this bifurcation here. We are going to pass this part first because this is the first thing to do. And we are going to build and train the model, passing as a parameter the ML context and the train set. This split data view full, it's basically the train test data that I told you before. This train set is the 0.9 of the reviews, and it's going to be used for training our model. So basically here we have this featureized text method. It's going to transform our input column, in this case text, into a column named features. That's basically an array of floats. This is going to be used for making predictions and probabilities. This is used a lot for example, for speech recognition. After doing this featureized text, then we are going to append the algorithm that we think we should use for our predictions. In our case, we are going to use this algorithm as DCA logistic regression with a label column name and the feature column that is going to be the same as this. Then we are going to have this estimator object, and with the fit method, we are going to train our model. So we are going to return our trained model. And after that, when we have everything, we can save our model. In our case, we saved it as a zip file because this could take a lot of time. So it's better if you have anything already saved. Maybe it can take around 5 minutes or could be more. In our case, it took around 5 minutes for a 40K review model. So I think it's not performant, and it's better to have it this way. So that's what we do here in this bifurcation. If the file exists, then we load the model, and it's just it just takes maybe a few milliseconds. Okay, after creating our training model, then we are going to evaluate the accuracy of this model. So for that we use our test set, the 0.1 that we talked before, and we are going to have another iDataView predictions object that it's going to hold our 0.1 reviews, but with the sentiment predicted. And also it's going to load some parameters regarding the accuracy of the model and things like that. Okay, so basically these are the steps for setting up our model. It's very simple, but it requires some knowledge that can be found in any Microsoft page. So after this, we are going to predict our reviews. For doing this, we are going to use some API and common usages, like for example, creating a review. And then we are going to see how this is done. So I have here our web application, and we can add some reviews here, like for example, this one. Sorry, I'm not running the app. Yes, I'm running the application. Okay, it was created. So first of all, we are creating our reviews and we are storing it in our database. But then when we want to get all the data from the API, then it's going to give us a model with a prediction. For doing this, we have this predict method. This predict method is going to receive a list of reviews, our ML context, and our model. So first of all, we load our reviews. We create a iData view object using the reviews stored in our database that are basically the reviews that we just created. Then we transform this iData view into our predictions. And here in this object, we are going to have all our reviews and the prediction if the sentiment was positive or negative. And after that, we can map our iData view in a review prediction that's going to hold our information. So that's pretty much it, what it takes to make a prediction. So let's see in our review list, we can write some more reviews, like for example, no related reviews like this, or maybe well, let's see what happens in our review list and the differences between our models. So here we have two lists of reviews, and we have this certainty. It basically tells that what's the probability of this review being positive. So for example, the 40K review set tells us that there's an 88% of chance that this comment is a good comment. And in this case, it tells that there's a 10% chances of this comment being positive. So it's making accurate predictions. In this case, for example, we can see that the chances are almost close to 55%. So it's because the comment is not related to anything. But here in the reduced model, we can see that the model predicted it as negative and with lower accuracy. So basically, there's no chance of anyone to tell if this is positive or negative. But we can see the differences between the models. We can see also that, okay, for example, this one, it's going to know that's a positive review based on the letters that it uses. So basically, it's pretty much it. We also can see the model metrics. For example, we have the accuracy of the model and some other parameters that if you want to look into them, it's I think most of them are like probability measures, but for example, negative precision and positive precision are very standard, and everyone can understand these parameters. So I think we are getting short of time, but that's pretty much it. And you can look into the Microsoft documentation. There's lots of examples, and it's very practical and easy to understand. So thank you all, guys. I hope that it was clarifying for everyone.
Well, I think we are both done, so if anyone has any questions or would like to ask something, you can write.
Yes, if anyone.
You can write in the comments.
Okay,
if there's no any questions or anything, well, I think that's it, guys. I hope you enjoyed.
Okay, yes.
I hope that we did the best of ourselves. So this was for you, and I hope you enjoyed.
Yeah, thank you guys for attending this talk, and we are very grateful for all. If you have any question, just feel free to reach any one of us
Exactly.
of anything.
I would like
thank you
to
guys.
point out